Now let's do this next question. If f of alpha is equal to integral 1 to alpha log t to the base 10 over 1 positive t dt alpha greater than 0, we expected to find f of e cubed positive f of e raised to the power of negative 3. Okay, so this is an interesting question. I hope you are able to see it. So we have to obtain this. Now we will have a small issue in this. Okay. So what is the small issue? The small issue is going to be with the limits. Now this is f of e raised to the power of 3, right? And this is f of e raised to the power of negative 3. Now for alpha is equal to e raised to the power of 3, we got f of e raised to the power of 3 is equal to integral 1 to e raised to the power of 3 log t. This is totally independent of alpha. So the log t divided by base 10 should be there. 1 positive t times dt. But for alpha is equal to e raised to the power of negative 3, you have f of e raised to the power of negative 3 is equal to 1 to e raised to the power of negative 3 log t divided by 1 positive t times dt. So the issue is that we have a different limit, but yet we have to add these two things. And above all, this will pose an issue for us. So what I'm trying to do here is I want to basically ensure that the limits are uniform in both ways. So how do we do that? So what I'm going to do is I'm going to rewrite this as integral 1 to e raised to the power of 3. Now let me use a base called e. Right. So by introducing a new base, I can rewrite this as log t to the base e divided by log 10 to the base e. Of course dt is there. Now this has got a denominator 1 positive t. So this is rewritten as 1 to e log t to the base e divided by, I can move this up, so it's going to be log 10 to the base e of 1 positive t. So this is a constant, so I can take that out, log 10 to the base e. So 1 to e log t, this is e raised to the power of 3, e raised to the power of 3 1 positive t. Now let me replace t with 1 over x. So dt will be negative 1 over x squared times dx. The limits will be, for t is equal to 1, x is equal to 1. For t is equal to e raised to the power of 3, my x is going to be 1 over, right, 1 over e raised to the power of 3. So this is going to be much helpful for us. So this is equal to log 10 to the base e integral 1 to 1 over e raised to the power of 3 times log of 1 over x divided by 1 positive 1 over x negative 1 over x squared times dx. Okay, now let me use another paper. We can add this in the frame. So this is equal to 1 over log 10 to the base e is equal to integral 1 to 1 over e cubed. I can write it as e raised to the power of negative 3. Right. So this is product sign. and I'm going to write log of 1 over x as x to the power of negative 1 divided by 1 positive 1 over x. I'm going to write x positive 1 divided by x times the negative 1 over x square times dx. Okay, so this is 1 over log 10 to the base c integral 1 to e raised to the power of negative 3. Now there's a formula log a raised to the power of b is b times log a. So this is negative 1 times log x. This is base e, right? Base e is here. Divided by, I'm flipping this x, so it's going to be x over x positive 1, and there is already a negative sign, so that will become positive here. There's 1 over x squared times dx, so x and x gets cancelled, giving you 1 over log 10 to the base e integral 1 to e raised to the power of negative 3, right? And this is going to be log x over x times of x positive 1 times dx. So this is what we got. Now if you remember, we took this to be equal to alpha, right? Alpha is equal to e raised to the power of 3. So I can rewrite this as, on the left is going to be f of alpha 1 over log 10 to the base e integral 1 to 1 over, it's e raised to the power of negative 3 is 1 over e raised to the power of 3, which is 1 over alpha. So 1 over alpha is here, and you have, now this is x, I can very well replace it with t. So t of t positive 1 times dt. Now for alpha is equal to 1 over e raised to the power of 3, which is nothing but e raised to the power of negative 3. You have f of e raised to the power of negative 3 is equal to 1 over log 10 to the base e integral 1. Now this is 1 over alpha, right? So I substitute 1 over e raised to the power of negative 3 log t divided by t times of t positive 1 times dt. So this is equal to 1 over log 10 to the base e 1 to, now if it goes to the numerator, this is e raised to the power of 3. So you have log t over t times t positive 1 times dt. So it's all base e. Now this is f of e raised to the power of negative 3. Now we know that f of e, let me use this term like this, right? So let me take this as say sum. We took the previous one as 2, so this is going to be some 1. So adding 1 and 2, right? So adding 1 and 2 we get, so this is f of e cubed is equal to, let me write the system down. So 1 over log 10 to the base e integral 1 to e raised to the power of 3. This is log t divided by t positive 1 times dt. This is one quantity, and f of e raised to the power of negative 3 is 1 over log 10 to the base e, and this is integral 1 to e raised to the power of 3 log t divided by t of t positive 1 times dt. Okay, so we are adding these two, so this is going to produce me f of e cubed positive f of e negative 3 is equal to, now log 10 is common, and then you can also take log 10 to the base e, and then you have 1 over t positive 1 in one case, and then 1 over t of t positive 1 in another case. So this limits are e 1 to e raised to the power of 3 times dt. Now we can simplify this. T of t positive 1, you get a t here, you get a 1 there, right, times a dt, and you have log t divided by log 10 to the base e integral 1 to e cubed. So t positive 1 and t goes out, so I'm taking the constant log 10 to the base e out. We have 1 to e cubed log t over t times dt. Now let some u be equal to log t. You differentiate du is equal to 1 over t times dt. So this is going to be 1 over log 10 to the base e integral. Now this is all to the base e is taken to be as u, and dt over t is going to be du. So you integrate this, you get 1 over log 10 to the base e, you get u squared over 2 limits. We don't have the limits, so what I will do is I will substitute the log value. So let me make the substitution or revert back. So this is equal to 1 over log 10 to the base e log t to the base e squared. It's a 1 over 2 is there, so I will place the 1 over 2 there. So the limits are 1 to e raised to the power of 3. This is how it looks. Okay, so it's going to be 1 over you have this 2 there, so I'm going to bring this 2 out. So 2 times of log 10 to the base e. Now I substitute the upper limit, so this is log e cubed divided, or I will say to the base e, minus log 1 to the base e. Right, so this entire component is raised to the power of 2. Right, so this is going to give me 1 over 2 times log 10 to the base e, 3 times log e to the base e minus log 1. Log 1 is going to be 0, and then this is raised to the power of 2. But log e to the base e is equal to 1, so you have 1 over 2 times log 10 to the base e 3 squared, which is equal to 9 over 2 times of log 10 to the base e. So this is the final solution. You can either write it like this, or you can write it as 9 over 2 times log 10. Okay, so this is an interesting question because of the requirement that has been posed to us in form of the limits. So thank you everybody. Please like, share and subscribe.